In this video, I'm going to go over the basic rules or laws of exponents. Now, I'm hopeful that when we're going through these, it'll feel like a review, since a lot of this was from your pre-algebra, Algebra 1 days. But if it doesn't, that's okay. This is a chance to practice some of those, and hopefully as it starts to come back to you, you'll feel more confident. All right, so let's start with these first two lines here. We have exponents. They will show us repeated multiplication. And the exponent represents how many times a number, which we're going to call a base, is multiplied by itself. So this kind of whole vocab area is helpful with the base of 3 raised to the 4th power. That's the exponent of 4, which is equal to 81. All right, so 3 times 3 times 3 times 3 is 81. All right, so let's start with some of these laws. Here's the first one. So we have the product of powers, where if you are going to multiply with the same base, then you're going to add those exponents. All right, so in this case, we have y to the 5th power times y to the 1st power. So I'm going to write y to the 6th power. Now the 7 and the 6 are not bases, right? They're not dealing with exponents. So just multiply 7 times 6 to get the number in front of that y to the 6th power. The next one here is going to be negative 3 times 5 first, which is negative 15. X squared times x to the 1st power, you're going to add 2 plus 1 to get x cubed. Y to the 7th power times y to the 6th power, we're going to add those together to get y to the 13th power. All right, so that's the product of powers rule. The quotient of powers is very similar. We're just going to subtract because we have division, right? Quotient, we have quotient, you know from your days in elementary school that's talking about division. So in this first one, I'm going to divide 35 divided by 7 to get 5. And then m to the 13th power divided by m to the 4th power. So if I write that over here, we're going to subtract these two numbers to get 13 minus 4, which is m to the 9th power. And then we just bring the n to the 6th power in the answer, since there's no other base of n. Okay, this next one here, I'm going to reduce 10 over 15 by dividing both of those by 5 to get 2/3. And then we have a to the 7th power over a to the 5th power is a squared. C to the 9th power over c to the 7th power is c squared. So the answer is going to be 2a squared c squared over 3. I'll center that 3 for you. Okay, negative exponent. If you ever have a base raised to a negative exponent, you can write it as 1 over that same base raised to a positive exponent, or going vice versa. These are a little bit tricky. You're going to see that basically the way you want to think of this is that they just kind of slide or move across the fraction bar. So like in this first example, do you see this c to the negative 5th power? I can write my fraction bar and write c to the 5th power in the denominator, and you'll notice that the power has become positive. All right, I'm going to keep the negative 3 up there and the 2 down here. The d to the 7th power is going to stay where it is, right? That's a positive 7. But then I'm going to take this e to the negative 8th power and move that across the fraction bar to get e to the positive 8th power. So that is it. I can't reduce anything. They don't have the same bases. Okay, let's do this one. Looks like almost everything needs to be moved except for this x to the 11th power. That's going to stick around. Then I have that 2 to the negative 6th power is going to go down to be 2 to the positive 6th power. Negative 5 becomes raised to the positive 2nd power. And the y to the 4th power in the bottom, since I moved that one across. And go ahead and clean this up just a little bit. That's 25x to the 11th power over 2 to the 6th power. Let's see, that's going to be 64y to the 4th power. Okay? All right, power of a power rule. This is where if you have a power raised to another power, we are going to multiply those exponents. So this is the most basic one here. X to the 6th power raised to the 11th power. You're going to do x to the 6 times 11 power, which is x to the 66th power. This one here, I've got a couple of things going on. I notice that I have a negative on the outside, right? So I'm going to do 1 over a to the negative 3rd power raised to a positive 4th power by putting it in the denominator. So that's 1 over, I'm going to multiply to get a to the negative 12th power, but I don't want to leave it there because it is a negative, so it's going to move to the numerator just to become a to the 12th power. Okay, let's do power of a product. This is where if you have those parentheses and you have two things that are multiplied inside, each of them gets raised to that power, or if it's more than two, like in this case, you get a lot. You get 4 to the 8th power times a cubed to the 8th power times c squared to the 8th power times d to the 8th power. So that's going to be 4 to the 8th power. I do not know what that is. I don't expect you to either. Times a to the 24th power times c to the 16th power times d to the 8th power. So putting that all together, we have this for our answer. Okay, this one here, I'm going to first, I noticed that it's a negative exponent, so I'm going to do 1 over 6 to the negative 2nd power, m to the negative 6th power, n to the negative 7th power raised to the 5th power, make it a positive now that I've put it in the denominator. Then I'll go ahead and do power to a power. So that's 6 to the negative 10th power, m to the negative 30th power, and n to the negative 35th power. But I'm not going to leave it like that because all those are negative, so they're all going to move to the numerator to become 6 to the 10th power, m to the 30th power, and n to the 35th power. All right, power of a quotient. This is where if you have a fraction, you can go ahead and raise it to both of them, the numerator and the denominator get raised to that power. So in this case, I'm going to do 4x squared to the 3rd power over y to the 3rd power. So in that numerator, 4 cubed is 64. X squared cubed, that's power to a power, so you multiply, you get x to the 6th power, and then y cubed in the bottom. Okay, this one is interesting, and I'll go ahead and show you kind of what I do here. There's kind of two ways to do this question in part B. I'm going to do it this way just because I think it'll help your brain. Not all of your exponents will be negative like in this case every time. But if I see a fraction raised to a negative power, I'm going to flip that fraction, so make it the reciprocal. So put d to the negative 11th, 5 to the negative 2nd, a to the negative 2nd power, and c to the negative 5th power. And then write it as a positive exponent. That's kind of the first thing I always do. And again, you may not do that on this one because everything was already negative, but it's a good kind of rule of thumb. If you see a fraction raised to a negative exponent, flip the fraction, so use the reciprocal, and change the power to a positive. Now, if you wanted to, you could go ahead and move all the stuff that's inside and then raise to the 6th power, or you could do a power to a power and all this first and then move them. It doesn't matter. You should get the same thing. So I'll do power to a power first. So negative 66 power. This is going to be to the negative 12th power, a to the negative 12th power, and c to the negative 30th power. And then they need to move across to become positive. So do my fraction bar. So in the denominator, I'll have d to the 66th power. In the numerator, I'll have 5 to the 12th power, a to the 12th power, and c to the 30th. Okay, next up is the 0 exponent rule. Anything raised to a power of 0 is equal to 1. So this whole thing being raised to a power of 0 makes it just 1. Very simple. This one's a little bit different. This is 8 times 1 plus 5, right? X to the 0 power is 1. It's not 8, right? The 8 is not being raised to the 0 power. Only the x is. So 8 plus 5 will give us 13. Okay, these rational exponents here, it's our last thing. This is some good practice for moving between radicals and rational exponents or fraction exponents. And you need to be comfortable kind of going back and forth between the two, especially as you move into your later years of high school. So when I look at this, the way it kind of works is whatever the denominator is, that's going to be the index of my radical. So I know we've done this a lot in algebra 2, even algebra 1. If I ask you to do the square root of 16, I don't write it, but there's a little tiny 2 in the index. All right, you don't have to ever write that because if it is the square root, you can just assume it is a 2 there. You don't have to write it unless it's something different. So if it was the 4th root, then I would have to write it, okay? So the way this works is you take the negative 64, you draw the radical, the denominator is the index, and then the numerator is the power that you're going to raise it to after you do it, okay? Now you can see here that if you wanted to, you could put that exponent inside if you wanted to. It's up to you. Feel free to move back and forth between the two. I think with all of these, I'm going to end up doing that power at the end. But you might decide especially if you have a calculator, it's much easier to just do it at the beginning. But I usually defer to it at the end. So the cube root of negative 64. So what number, when I cube it, gives me negative 64? That's a negative 4. And then now I still need to square it. So that's going to give me 16 is my simplified answer. Let's try this next one. So negative 144. I'm going to write the square root. If you wanted to put that 2 as the index, you could. And if you wanted to, I'll just do it. We'll put it to the first power, you could. But I'm just going to write negative 144, the square root of that. Raising something to the first power doesn't change it. And you actually can't do this, but if you wanted to involve your understanding of imaginary numbers, the square root of negative 144 is 12i. Okay, let's do this next one. We have that square root of negative 4 raised to the 5th power. Again, the square root of a negative number is not possible. We'll go ahead and call this 2i raised to the 5th power, which would be 32i to the 5th power. Ooh, this keeps going. I didn't realize that. 32i to the 5th power. We know that I squared is negative 1, so we do 32 times I squared times I squared times I. Right? So that's going to be 32 times negative 1 times negative 1 times I. That's going to be a positive 32i. Okay, let's do this last one. This is the square root of 25 cubed. The square root of 25 is 5. 5 cubed is 125. All right, so that is a lot of examples, a lot of rules we just flew through. So check out the homework. Come see me if you have any questions.